Hi, good day everyone. As promised, I'm going to teach you kssm Physics Form 5, Force and Motion 2, subtopic 1.1, Resultant Force. Okay, by the end of this lesson, we should be able to describe resultant force. Okay, number 2, determine the resultant force. Number 3, communicate about resultant force. Or symbol for force is F when an object is in situation number 1, stationary when F is equal to 0. Situation 2, object moving with constant velocity or F is equal to 0 when F is equal to 0. And situation 3, object moving with constant acceleration when F is not equal to 0 Newton. And situation number 4, solve problem involving resultant force, mass and acceleration of an object. Okay, so let's recall our prior knowledge. Okay, what do you understand about the force? Force is an action of pull or push. Okay, we can describe force from Newton, second law, first law, and also third law. But what we're going to rephrase or what we're going to focus on this topic is Newton's second law, which is F is equal to ma. F is equal to force in Newton, M is equal to mass in kg, and A is equal to acceleration in meter per second. We have a lot of forces, type of we can state type of force. We have a lot of forces. For example, the picture number 1 is not very clear. This is actually a rocket. Okay, a thrust force, that means force pointing upward. Okay, second force is a person try to ignite a fire using a stick, and also dry leaf or something else. Okay, this we call as frictional force. The apple falling downward or any object falling downward. Okay, we can call this force as gravitational force. And a person standing a person, okay, it's the force that acting on this person is upward force and also downward force. Okay, upward force we call as reaction. Okay, downward force we call as weight. The same goes to our apple. Apple also we call as weight. Okay, or gravitational force. Okay, we have another situation here. A person, this person try to pull a rope, and another person, while another person try to push something. Okay, this we consider all situation here is force. Okay, they involve the situation here involve forces. Okay, type of forces that we're going to learn. Okay, so here is the question. How to determine the winner in tug of war competition? Okay, how can you determine the winner in tug of war competition? Okay, so based on the for me, okay, based on the team that can pull the rope ni with greater force. Okay, the team that have higher forces or greater force will win the competition because they can pull the opponent towards their direction. Okay, towards their team's direction, or they can defeat the other team. Okay, so we have a situation here. Resultant force. What is resultant force? Okay, resultant force is a single force that represents the vector sum of two or more forces acting on an object. So we have a box here. We have two types of force acting on this box. Okay, you have to consider lah the direction because force is a vector quantity. Okay, force has magnitude and also direction. Okay, we have to consider two things, magnitude and also direction. First thing first, okay, we calculate the magnitude. We have force number 1 acting to the left, magnitude of 20 Newton, and the other force F2, okay, magnitude of 20 Newton acting to the right. Okay, how to find resultant force is the sum of the force. Okay, sum of the force, that means you have to um, consider the greater force. Okay, but in this situation, we have the equal magnitude of force. So the resultant force is equal to 0. Okay, if two forces of same magnitude but opposite direction are applied on stationary object, the object remain at rest. So from the resultant force, we can say that both of force is equal even though it is in different direction. So the object, we call this object stationary. Okay, the object is in the state of stationary. Our object is not moving. Okay, next, if two forces of different magnitude and direction are applied on stationary object, the object will move in the direction of larger force. Okay, so see here. Okay, same goes to the example just now. Okay, but we have two forces with different magnitude and also different direction. So how to find a resultant force? We have to sum. We have to find the sum of two vector of forces. Okay, that means you have to find the greater forces minus with the smaller forces. Okay, 80 minus 20. Okay, you will get 60 Newton. Okay, you have to find the direction. Direction will follow the force with this which has higher magnitude. Okay, we have F1 is equal to 80 Newton. So 60 Newton to the left. That is the resultant force. Okay, so we have four situations here. So I want you to try to determine what is the resultant forces. Okay, situation number one. Okay, find the magnitude first. Okay, then you find the direction. Then you will find the what is the resultant force of the resultant force of situation number one. Okay, situation number one. Okay, 40 minus 20, 20 Newton to the right. Okay, situation number two, 80 and 40. You find the greater forces. Okay, it's easy. Okay, find the greater magnitude of force. Okay, then you will state the direction same to the greater forces direction. Okay, 40 Newton to the left. Okay, here equal magnitude of force. Okay, so the object, we call this object as in the state of stationary, or the object is at rest. The force situation 60 and 20. 60 minus 20 is equal to 40 Newton to the right. Easy, right? Okay, so we come to the other situation. Okay, how to find resultant force of two force acting perpendicularly to each other. Okay, just now the force acting horizontal. Same goes to vertical. If both of the forces is in vertical, you can straight away sum up the vector of the forces. Okay. But in this situation, if we have two type of force acting on the same object but perpendicularly to each other, what you need to do? Okay, number one, you have to arrange the force into a free body diagram. Number two, create a triangle from the diagram. And number three, okay, the resultant force will be the third line that create triangle. Okay, let's see the example. Okay, what is free body diagram? Free body diagram represent the axis of x and also axis y. It depend on you lah. You can use your touchpad and draw your free body diagram. Free body diagram represent the object lah, object itself. If here in this situation we have a box, there is a force acting upward and also acting on the right. Okay. Okay, so we have situation here. Force perpendicularly to the motion, we have F1. We consider F upward as F1 and the other force to the right consider as F2. Okay, object, you have to make sure the vector of the forces is the same direction as the question lah. Okay, ni acting upward acting upward, and the other force ni, the second force acting to the right. Okay, so How to find the resultant force? Resultant force will be the hypotenuse of the hypotenuse of the triangle. You have to create a triangle then. Okay, you have to create a triangle. That means the other force, the resultant force would be your hypotenuse. Okay, here is your resultant force, the red color arrow. This is your resultant force. Okay, next example, find the magnitude and direction of the resultant force. How to find the resultant force? You have to know the magnitude first. Magnitude of the force. Okay, F1 is equal to 8 Newton, F2 is equal to 6 Newton, for example. Solution. Okay, you have to use theorem Pythagoras formula lah. Okay, c square is equal to a square plus b square. Okay, c square is your hypotenuse. Okay, your hypotenuse will be your resultant force. Okay, a square 8 over 2 plus 6 square. Okay, F resultant is equal to 10 Newton. You have to square root lah. The answer, you get the magnitude of the resultant force is equal to 10 Newton. So you have to find the direction. How to find the direction? Okay, direction of the force. Okay, this is the angle lah. Okay, how to find the resultant force, direction of resultant force. Okay, you have to use tan lah. Tan theta is equal to 6 over 8. So theta is equal to shift tan or tan 6 over 8. You will get the direction is 36.9 degree. Okay, just take 36.9 degree. No need to stick towards northeast, northwest ke, no need. Okay, just the angle. Angle will represent the direction. Okay. Okay, situation number. Next situation. How to find resultant of two forces acting not perpendicularly to each other. Okay, we can use two methods. Okay, first method is triangle method. How to use triangle method? Okay, number one, you have to choose a suitable scale according to the force magnitude. Okay, you have to use the exact scale, but you can minimize the scale. If the scale, for example, if you use if the force here, given the force magnitude of the force is 10 Newton, you can convert 10 Newton into 10 centimeter. Because triangle method ni you have to draw. You have to draw the triangle. Okay, you have to decrease the scale. Okay, draw F1 and F2 to form two sides of triangle. Okay, same goes to our previous example just now. The third line will be the resultant force. Okay, let's see how we can do this. Now we can solve this question. Okay, so this is 30. This is we consider as F1. You have to consider direction of force as well. Okay, we have on this picture, we have a container here be towing by two boat A and also boat B. So the force that acting on this poses by this rope is tension. Okay, tension force that poses by the rope. Okay, we call it as tension 1 and also tension 2. Okay, so P1. Okay, you have to already draw the arrow. Arrow will represent the direction of the force. Okay, this is 30. 30 is here. Okay, this is 40. 40 and here is 50. Here is 50. So I have removed or I have changed the I have transferred the force ni towards the other side here, because you also can get the same force but in different location. Okay, the same force, exactly the same force, but we just transfer the force into a different spot here. Find the resultant force. Okay, another tips is you have to make sure your vector of force ni attached to each other. Okay, direction ni attached to each other. Okay, like passing the baton lah. Okay, here one force and you join with other force, like passing the baton. If you you cannot connect this force, the at the end of the force to another force straight away like that. No, I cannot. Okay, you have to pass the baton. Okay, this is one vector of force and join the other force. Okay, you get the this is the the resultant force. You will get the resultant force here. You have to draw, okay. Maybe we need a graph paper to make sure you get the accurate force or accurate resultant force. Okay, so just draw. Okay, after you finish, draw the force, and you will get the correct resultant force. Okay, so next, how to find resultant force of two forces not perpendicularly to each other. Okay, we also can use another method, that is parallelogram of force method. Okay, this method, step number one, you have to choose a suitable scale according to the force magnitude. Same goes to our previous example. Draw F1 and F2 to form two side triangle. And method, the third line will be the resultant force. Okay, most likely the same, but we have some difference. Okay, so this is the axis for free body diagram. Okay, from our previous, okay, the same question. Okay, with the same value. Okay, so how to draw the parallelogram method? Okay, here you have to use, if given to you the magnitude of the force. Okay, the magnitude of the force will represent the scale of the force. If 70 Newton, you can change to 7 centimeter. Okay, if you have another force here, 50 Newton, you can change the scale into 5 centimeter on your scale when you draw on the graph paper. Okay, so 60, 40, 60. Okay, how you get the value? Okay, same like this lah. Okay, if we have this value here, value 50, and this is 30 and 40. It's not right angle, because the angle from force number 1 to force number 2 is 80 degree. Okay. Okay, so 40 and 60, sini we dapat 50 kan. Okay, so you have to use the same scale lah, 70, 70, 50, 50, and you will get you will find your resultant force. Okay, second law, express as F is equal to ma if the number of force act on object at the same time, F represent the force on an object. This is Newton's second law. Okay, resultant force on an object in various state of motion. Okay, so if we have an object here, then you have to draw every possible force that will act on this object. Okay, the possible force is reaction and weight lah. If the object is stationary. If the object is stationary, so the object didn't have any acceleration, no acceleration, no velocity, and also no displacement, zero. Okay, so if velocity is 0 meter per second, acceleration is equal to 0 meter per second, resultant force is equal to W is equal to R, because we don't have any horizontal force. We only have vertical force. Okay, W is equal to R. We call this object is in stationary state. Okay. Okay, but in second situation, if velocity is constant, that means object is moving. Okay, acceleration is 0. Constant velocity is 0 acceleration. Okay, what is it? Resultant force? Okay, resultant force, as we know, okay, the thrust is equal to friction, and also reaction is equal to weight. All the force is equal to each other. Okay, object is moving with uniform velocity. Okay, this we call as the horizontal force, and the other force is vertical force. Okay, and next situation, if velocity increasing, for example, acceleration is equal to 50 meter per second square, resultant force is equal to 50. For example, resultant force is equal to 50, that means if the object is accelerate, that means we can automatically predict the thrust is greater than friction. the thrust is equal to is greater to friction. That's why the object can accelerate. The object only accelerate if the thrust is greater than friction. Okay. When the object is decelerate, that means friction is greater than thrust. Okay. Same goes to our reaction and also weight. Okay. Weight is equal to reaction. Okay. Then object is moving with acceleration. Okay, you can predict lah. From the motion, you can predict what is the force. Roughly lah, you can roughly know what is the value of the forces. Okay. Hope you clear with my explanation. Okay, we have a question here. Figure 11.1 show a toy car of mass 0.5. Okay, on table being pulled by a load using a pulley. A toy car moves with acceleration of 2.8 meter per second square against friction of 3.0 Newton. Gravitational acceleration given by 9.81 meter per second. Sketch the free body diagram of toy car and the loop. Okay, sketch the free body diagram. Please underline and make sure don't forget to list down all the value given in the question. Okay, use W as weight of toy. Okay, if the question already given to you, then direction like this, instruction like this, please follow all the instruction given. Okay, R is equal to normal reaction on the toy car. Fr is equal to friction. T is tension of the string, and B weight of the load. Okay, B compare the weight of the toy car W with the normal reaction R. Calculate the resultant force acting on the toy car F. Okay, calculate the tension in the string pulling to the toy car T. What is the mass of the load M? Okay, so this is the diagram. Okay, so we need to draw the free body diagram. Okay, this is the free body diagram. You have to draw all the possible forces. Okay, I think I have. Yeah, so sorry. Okay, here is the actual diagram. Okay, this is the free body diagram for this question. Okay, R, please make sure you follow all the weight of the toy car. W, suppose W not WA. So W je. Okay, wait. R is the normal reaction on the toy car. Okay, R. Given R, reaction acting upward. FR, friction. FR. Okay, we have FR in here. T, tension. T, tension. We have two T. Ada T, two. That means this is the same string. The same string, but it acting in different direction. Why? Because we have two free body diagram. If the question want you to draw the free body diagram on the toy car, then this is the free body on the toy car. Okay, this is the free body diagram for the loop. Okay, but I want you to ni lah the tips, not the tips lah. I want you to make sure. I want you to understand that this string acting in different direction. Why? Because this string hold this load and also hold this toy car. Okay, the direction of the force acting on the load, string on the load is acting upward. The string acting upward on the load, and also the string acting towards the right. Okay, to the right, the direction of the string to the right for the toy car. Okay, this is the free body diagram. Make sure you draw all the possible force. Okay, but this is exception for this question. You already the question already give everything, so you just follow the instruction. Okay. Okay, next, compare the weight of toy car W with the normal reaction. Okay, object is stationary, as I told just now. Okay, object is stationary. That means there is no force acting on horizontal. We only have force on the vertical side. Okay, R is equal to WA. What is WA? Okay, W je. WA, W weight of the toy car. Okay, reaction of the toy car is equal to weight of the toy car. Okay, calculate the resultant force acting on the toy car F. Okay, how to find the resultant force? Okay, we can use the formula of Newton's second law. Okay, please list down all the information given in the question. Mass of the toy 0.5 kg, acceleration of the car 2.8 meter per second square. Given this is Newton's second law, F is equal to ma, F is equal to 0.5 times 2.8. So you get the resultant force is 1.4 Newton. Okay. You can straight away get the resultant force from the formula of the Newton's second law. Okay, next. Calculate the tension in the string pulling the toy car. Okay, this is when you need to draw the whole free body diagram on this object. Okay, so we already have the resultant force is equal to 1.4. Friction, this is friction, 3 Newton. Okay, resultant force on horizontal. Okay, F is equal to ma to Newton's second law. Dia acted on the horizontal axis. Okay, acted on horizontal axis. So F is equal to ma because the object ni only accelerate on horizontal axis. Okay, so F resultant is equal to tension. Okay, we have two type of force on horizontal. Okay, tension and also friction. But if the object moving with acceleration, that means we know lah, the object accelerate to where? Okay, to the right. Okay, the right forces is greater than the left forces. Okay, so that's why we need to minus tension minus friction. Tension because tension is greater. Object is accelerate, object is accelerate, that means tension is greater than the friction. Okay, resultant force is equal to tension minus friction. So we want to find the tension. Tension is equal to resultant force plus your friction. Okay, so tension is equal to 1.4 plus 3.0. So tension is equal to 4.4. That is the tension in the string pulling the toy car. Okay, this is how you find the value of the tension. Okay, next, what is the mass of the load M? Okay, how to find mass of the load M? Okay, given tension is equal to 4.4 Newton. Okay, from the formula of Newton's second law, F is equal to ma. Okay, what is WB? Teacher yang buat WB. Okay, WB ni load load here. Okay, F is equal to ma. Okay, MAF. Okay, on the load ni we have two type of force ni we call as the vertical forces. Okay, we have two force here. Okay, if the object is accelerate downward, that means WB is greater than T. Okay, accelerate downward. Okay, on this free body diagram, T is greater than F. But for second free body diagram on the load, WB is greater than T. Why? Because it accelerates downward. Okay. Okay, we have to measure one by one. Measure one by one. Okay, this is the actually this is a one system, but it is easier for you to calculate one by one. Free body refer to free body diagram. WP minus T is equal to MA. MA given to you in the question. A is equal to 2.8. Okay, so substitute into the formula. WB weight is equal to mg. Mg, G is equal to 9.81. 9.81 m minus T is equal to 2.8 m. Okay, so calculate, you akan dapat m is equal to 0.63 kg. Yeah, I hope you understand. Okay, elevator. Okay, this is elevator. Sorry, to change this. Elevator. Okay, the elevator situation. Very easy. Okay, okay, in this situation, okay, object moving with zero acceleration. No, not accelerate. That means it moving with constant velocity. Constant velocity, that means it acceleration, right? Okay, from Newton's second law, F is equal to ma. Okay, A is equal to 0 kan? Okay, so we have two type of force here, reaction and also weight. Okay, ada only two forces, and as we all know, elevator only moving upward and downward kan? We don't have elevator that moving side by side. Okay, elevator moving up and down. That means we only consider the vertical forces. We have reaction and also weight. Okay, so when the acceleration is equal to 0, so we refer to this formula, F is equal to ma. When A is equal to 0, that means only F lah. Betul tak? Only F ya. Inside this, F is equal to 0, betul? F is equal to 0. So, that means R minus W, F, we consider F ni kita akan refer to all the possible forces acted on this object. Okay, so we have R and W. R minus W is equal to 0. So R is equal to W. What is R? Reaction. What is W? W is weight. Object is moving with constant velocity lah. Constant velocity. Elevator. Constant acceleration, not accelerate. Constant velocity. Constant velocity. Acceleration is 0. Okay. Okay, next. Elevator as well. Okay, we have second situation. This elevator accelerate upward. Okay, we have acceleration upward. So same goes to this question. We only consider the vertical forces. Okay, from Newton's second law, F is equal to ma. So from this situation, we know when the object accelerate upward, the upward forces is greater than downward forces. So R is greater than W. R is greater than W. So we know lah, the value magnitude of force upward is greater than force downward. So we have to minus lah, R minus W, because we know the greater force is reaction. Okay, reaction minus weight is equal to ma. Where you get ma? From this lah. F ni we consider all the forces. Okay, R is equal to ma plus W. Okay, W is equal to weight kan? Weight is equal to mg. R is equal to ma plus mg. Object is moving upward with an acceleration. Okay, next situation. Elevator as well. Okay, object moving downward with acceleration. Okay, we have two type of force. F is equal to ma. So if it moving downward with acceleration, W is greater than R. Weight is greater than reaction. W minus R, we have to we use W. W weight have to minus with R. Why? Because W we know W is greater than reaction. W minus R is equal to ma. R is equal to W minus ma. R is equal to mg minus ma. Object is moving downward with acceleration. Okay, we have question number 2. A durian of mass 1.5 kg fall from the tree with acceleration of 7.5 meter per second square. In figure 1.9, sketch the free body diagram of the durian. What is the resultant force F acting on the durian? Determine the direction of the resultant force. Find the magnitude of the resultant resistance acting on the durian. Gravitational force given by 9.81. Okay, here is the free body diagram. Falling of durian. Okay, only vertical forces involved. Okay, R and W lah. R is reaction, W is weight. Please write down it properly. Weight. Weight. Reaction here. Reaction. Okay, so we have two forces acted on this object. Okay, next, what is the resultant force acting on the durian? Okay, given the acceleration is equal to 7.5. Okay, F is equal to ma. M given the mass of durian is 1.5 times 7.3 is 7.5. F is equal to 11.25. Okay, then you get the resultant force of the durian. Okay, determine the resultant force direction of the resultant force. Direction of resultant force of the durian is downward since it's accelerate downward. Okay, next, find the magnitude of air resistance acting on the durian. Okay, resultant force, that means you have to know the object resultant, resistance is the force that always oppose the direction of the motion. Okay, durian moving downward, so the resistance would be the direction which is opposite to the direction of the motion, which is downward. That means upward would be your resistance. Nah, R ni reaction, we will consider reaction force as the resistance. Air resistance. Okay, find the magnitude of the air resistance acting on the durian. Okay, so as we know, the durian accelerate downward. Okay, the downward forces is greater than the upward forces. So, weight minus reaction. Weight minus reaction is equal to F. Okay, the force, the force. Okay, R is equal to W minus F. Okay, R is equal to 1.5 times weight, the mg, mg minus resultant force. Okay, you don't need to find MA because you already have the magnitude of the resultant force here. The resultant force involved here is only F. Okay, R is equal to 3.47 Newton. Okay. Okay, question number 3. A woman of mass 50 kg is standing in a leaf. Gravitational acceleration G is 9.81 meter per second square. Figure 1.10 sketch the free body diagram using symbol W for the weight of the woman and R for the normal reaction from the floor to the leaf. Okay, determine the magnitude of normal reaction when leaf is stationary, moving upward with acceleration of 1.5 meter per second square and moving with uniform velocity of 9.2 meter per second. Okay, how to solve this question? You have to draw the free body diagram first. Okay, sketch the free body diagram using symbol W for weight and R for reaction. And you know how to draw the free body diagram. Right? Okay, next. Okay, reaction force when the leaf is stationary. You have to find the R when the leaf is stationary. Stationary when A is equal to 0, acceleration is equal to 0. F is equal to ma from Newton's second law. You're going to use this Newton's second law in this whole topic. Okay, R is equal to Wy because A is equal to 0, R is equal to W, R is equal to mg. So substitute 50 times 9.81, you will get the reaction force is equal to 490.5 Newton. Okay, next. Now, moving upward with acceleration of 1.5 meter per second square. Okay, stationary, but moving with acceleration of, moving upward with acceleration. This is not stationary lah kan? Object moving with acceleration. Okay, A. Okay, object moving with upward. Object moving upward with an acceleration. So you know from this formula, Newton's second law, R is greater than W. Why? Because it moving with acceleration upward. Okay, R is greater than W. R minus W is equal to MA. R is equal to MA plus MG. So substitute into the formula. A is equal to 1.5, G is equal to 9.81. Then you will get reaction force is equal to 565.5 Newton. Okay. Last question, moving with uniform velocity of 9.2 meter per second. Okay, acceleration is equal to 0. Uniform velocity, uniform velocity that means 0 acceleration. So same like our previous question. F is equal to A, R is equal to W. Then you get reaction force is equal to 490.5 Newton. Okay, that's all for today. Thank you so much for watching my video. I'll wait for our activity on this Thursday. Please bring your graph paper. Bring your graph paper. We will do some activity. We're going to find the resultant force using parallelogram method and also triangle method. Okay, bye for now. Thank you so much.